Hello, our project is breast cancer survival prediction. The goal is to use SEER breast cancer registry data to predict breast cancer specific mortality risk based on information available at diagnosis. This website is our final M6 deployment deliverable. It connects the full project process from M1 to M6. Research question, data acquisition, data cleaning, exploratory data analysis, modeling, and the final deployment. On the homepage, we show the overall project structure. The website is designed as a presentation route. Each page represents one milestone, and the final page is a live interactive demo. Now I will go through the project step by step. First, M1 research question. In this stage, we define the main prediction problem. Our research question is, can clinical and demographic features available at diagnosis predict breast cancer specific mortality? The key point is that we only use diagnosis time information, such as age, stage, subtype, tumor size, grade, lymph node status, and metastatic sites. We do not use future outcome information as in features because that would cause data leakage. This project is a prediction task, not a causal analysis or treatment recommendation system. Next, M2 data acquisition. Here we describe the dataset. We use SEER breast cancer registry records. SEER provides structured information about patients' demographics, tumor characteristics, cancer stage, molecular markers, lymph node status, metastatic indicators, and survival outcomes. At this stage, we identify the feature groups that are relevant to the prediction task, including age, race, income, context, stage, subtype, grade, tumor size, lymph node involvement, and the metastatic sites. We also discuss data risks because SEER is a registry dataset and may not fully represent all clinical populations. Then M3, data cleaning and pre-processing. This page explains how we turn a raw registry records into a modeling-ready dataset. We filter construct the binary target label for breast cancer specific mortality, clean clinical variables, handle missing and unknown values, and prepare features for modeling. A very important part is leakage control. Variables such as survival time, mortal status, and cause-specific death information are used to define or audit the outcome, but they are not used as ordinary prediction inputs. Next is M4, exploratory data analysis. In this stage, we examine the major patterns in the data. The EDA shows that stage is one of the strongest risk signals. More advanced stages are associated with higher mortality risk. Molecular subtype also matters, especially triple-negative breast cancer, which tends to show high risk. Tumor size, age, and positive lymph nodes are also important clinical indicators. The purpose of EDA is to connect data patterns with clinical intuition and guide the modeling choices. Then we move to M5 modeling. Here we compare multiple models, including baseline and advanced medicine learning models. We evaluate models using metrics such as PRAOC, AUROC, F1, precision, recall, and BRAF score. PRAOC is especially important because breast cancer-specific mortality is a relatively rare positive classes, so accuracy alone would be misleading. Based on the comparison, we select biofusion as a final model because it provides the strongest overall performance and can capture nonlinear interactions among clinical features. Finally, M6, deployment demo. This is the final working demo. Users can enter a patient profile using diagnosis time features such as age, stage group, molecular subtype, grade, risk subgroup, tumor size, positive lymph nodes, income context, and metastatic sites. After clicking Calculate Risk Tier, the demo returns a predicted risk probability and a risk tier, low, medium, or high. Now I will show three typical examples. The first example is the low-risk profile. The patient is 58 years old, stage 1A, HR plus, HER2 minus, grade 1 with 12 millimeter tumor, no positive lymph nodes, and no metastasis. This represents an early stage small tumor, low-grade case. The model returns about 2.75%, which is low risk. The second example is a medium risk profile. The patient is 64 years old, stage 2A, HR plus, HER2 minus, grade 2, no positive lymph nodes, and no metastasis. Compared with the first case, the stage and tumor size are higher, so the risk increases. The model returns about 11.5%, which is medium risk. The third example is a high-risk profile. The patient is 82 years old, stage 4, HR minus, HER2 minus, which corresponds to triple-negative breast cancer, grade 3, 8 positive lymph nodes, and liver metastasis. This profile contains multiple high-risk factors: advanced age, triple-negative subtype, high grade, large tumor size, high lymph node burden, and distant metastasis. The model returns about 75.9%, which is high risk. To summarize, this website demonstrates a complete data science pipeline. Start with clinical prediction question, acquire and clean seer data, explore important patterns, compare models, select biofusion, and deploy the final model as an interactive web demo. This project is for research and cross demonstration only. It is not intended for real clinical decision making. Thank you for your attention.